Very cool. Welcome, Will. So you are the CEO of Lightning AI, the platform to train, deploy, and build AI with Pytorch, lightning fast. You are based right here in New York, so on 23rd Street.
4 blocks away.
Four blocks away, so local AI. And you have raised about 60 million in venture capital, most recently a 40 million Series B in 2022, at least based on what's announced. So you've had a very prolific last few weeks or months with two things: the release of Pytorch Lightning 2.0, and then Lit Llama, which is your own generative model. So I'd love to use this as a framework for discussion. Start with Lightning and then go into Lit Llama. So maybe just as a level set, so what is Pytorch and what was the journey from Pytorch to Lightning?
Yeah, well, first, thanks for having me. Thank you all for coming. Hopefully you get something interesting out of this. Yeah, so who's heard of Pytorch? Raise your hand. Great. Who's heard of Lightning? Anyone? Great. Love it. Who hates Lightning? Raise your hand. One person.
Are you raising your hand?
All right. I love Lightning, but maybe I'll convince you not to hate it. Anyways, so Lightning started in around 2015. Pytorch happened a few years later, so you're like, but how is this related? So I was an undergrad here at Columbia, and I was working in computational neuroscience. And at the time, we were using GANs and autoencoders, which are all the rage back then, to try to figure out what was encoded into certain neural activity, right? So we measure neural activity in some animals, and then we use a model to take that neural activity and reconstruct. For us, it was ImageNet, so images. We published a paper at NeurIPS about that, which was fantastic. Last time I published at NeurIPS, didn't happen again. But so while I was working on that, I started with Theano, and then I moved into TensorFlow and then Keras. And what I always found was that everything was overly verbose and very restrictive. Like at some point, you just needed the flexibility as a researcher to do things, and the framework locked you in. And so I basically started building my own library for my own research purposes as an undergrad, so I could go between research ideas without changing too much of my code, right? And today, that's still true, right? And if you're working on deep learning at a company or ML, what tends to happen is if you don't have something like Lightning, you will have to write your whole project, and then you'll have to clone it, and then whatever you did to that, you have to re-implement it in the other one. So if you added multi-GPU support, now you have to do that on the other one as well. And very quickly, you have too many forks, and it's really hard to maintain, and nothing ever works after that, right? If you're doing your own personal project, you probably haven't really noticed this until you start to collaborate with people. So that was a problem that I had because I was collaborating with a lot of people. So basically, over the last, 7, 8 years, you can think about Lightning as research into how should deep learning code be structured, and what should be factored out, and what should live where, right? There's no standards like that for deep learning. There are for React and web and everything else. For deep learning, we've kind of set a lot of those standards now. And you see them in other libraries that are not Lightning today, the way that they adopt their APIs, because it does give flexibility, which is great. So Lightning evolved based on that. Now, that was a private project that I had for a very long time. Eventually, I started my PhD at NYU, and I was working here with Kyung-Hyun Cho, who did a lot of work on seek-to-seek and GRUs, if you read that paper. And he's at Genentech now, doing amazing things. And then Jan LeCun, who everyone has heard of as well. And they were my PhD advisors. And so there, I took this project that I had, and I started using it for my PhD again. And I realized that it actually allowed me to try ideas very, very quickly. And it kind of stood the test of time at that time. It had been a few years. And I could actually work on I actually started working on NLP at first. This is pre-transformers, right? So we were doing a lot of decoding, seek-to-seek with attention, that kind of thing. Then I worked on audio, so speech syntheses. Then I worked on video, on images. So again, back to how do we represent images. And then I open sourced Lightning at that point. It was around April or May of 2019, mostly so that other people at NYU could access it. I was sending the code over Slack. I was like, okay, how about we just pip install the thing, right? And so just open source it for that. I was not, my goal wasn't to build anything crazy with it. And so I just open sourced it, named it, put it out there, and then I joined Facebook AI Research after that. So at Facebook, we started training on YouTube. So we were trying to train a contrastive learning model, self-supervised on YouTube. And YouTube's very big, and Facebook has a lot of GPUs. So my advisors were like, what if you had all the compute in the world? What would you do? I was like, well, I'm definitely going to train on videos, and I'm going to use as many GPUs as I can. So this is 2019. Lightning, at the time where I sat at Facebook, which is actually, where are we? It's a few blocks from here, actually. Next to me was Sumit and the Pytorch team. Behind me was the people from Fairscale. So if you know FSDP and that, like all these distributed strategies, it's these guys. There's another team. Most of them are Character AI now. So there's a few, like it was very early. Fair was only about 100 people back then. So it was early days of like distributed training. We just gotten DDP to work. And then I started implementing a lot of this into Lightning. And I started running jobs in the Facebook cluster where one model would train on about 1,000 GPUs, right? The Facebook cluster has a 3-day limit where they shut it down because it's a Slurm cluster, so you have to share it. So every 3 days, the model gets killed, and you have to resubmit the job. So I'm not going to sit here and like manually resubmit, so I built fault tolerance into it, right? So Lightning would like detect the signal, save itself, and then restart again and continue training. We trained these models for about 3 months at a time, continuously, right? Today, I think the world's starting to do that. They're like trying to figure out how do you train models on 1,000 GPUs over 3 months. Lightning's been doing that since 2019. Like literally, it's why it's built for that, right? Like that's how it started. Back then, we were using like half precision. Apex had just come out from NVIDIA. So a lot of these tricks that we're putting into it. Over the years, Lightning's evolved into a place where really what I wanted was a place where all of the research in the world and all the tricks can live in single place for the benefit of everyone. And that's happened today, right? So that's kind of the story of it. Lightning's evolved since then to become a platform as well. So we have Pytorch Lightning, which is what I'm talking about here. We have Fabric, which is basically the Lightning internals as a standalone pieces that you can actually put into your Pytorch code. And you can build your own trainers. You can build your own LLMs. If you worked on LLMs and kind of large-scale training, you probably got annoyed at Pytorch Lightning because you had to mess with the trainer, and the trainer does that for you. So we actually give you a way to write your own trainer, and that's what Fabric does. That was released in Pytorch 2.0. And then we have the Lightning platform on the cloud, where we actually can help you train on the cloud, deploy, and we'll get you the GPUs, and all of that infrastructure stuff is kind of like gone, and you can actually work with your teams and build AI together. So that's kind of the full stack of our offerings today as well.
Great. And what are some examples of what people do with the framework?
Yeah, so who's heard of Stability AI and Stable Diffusion? That was trained using Lightning, right? Thousands of GPUs on AWS. You can go to the GitHub repo and see that today. OpenFold, also trained with Lightning. There's NVIDIA just announced all these NeMo services. Those are all powered by Lightning. There's over 10,000 companies across the world who use Lightning to train, deploy. Facebook, a lot of it is powered today by Lightning. You have other major companies, which I won't talk about here because I don't know if I've gotten permission, all the way from banks to self-driving car companies to tech. Probably if a company is using AI today, there's a team internally who's at least using Lightning for something. So we work with a lot of companies on how do we help them standardize more of their code across the org. And you know, if you're training LLMs or using APIs, do other things, we can help you do a lot of that.
Great. So where does Llama fit into that picture?
So we've always been kind of like at this level of infra. We're like kind of like the mechanics in the F1 team. We're like always building like these really fast cars, and we're like, we know we can do this, but we've never actually ourselves put an F1 car on a track. So this is our way of doing that. So Llama is a very, very high performance model. So if everyone's familiar with Llama from Facebook, that model was released under a GPL license, which means that...
Do you want maybe to go into what Llama does for anybody that may not be familiar?
Yeah, so Llama it's a language model, right? So it's like an open source alternative to like a ChatGPT, for example. So you can grab it from open source, and then you can use it like you would with ChatGPT. And there's many technical ways of doing that. Now, when that open source repo was released by Facebook, they only gave you the code to do inference, meaning to predict with it. And the model weights were also not like given out. You actually sign up for them. Now, the code on the repo is GPL, meaning if you do anything with that code, you have to open source that stuff. That's what the GPL license does, which means it's kind of not, and they did it because they want to keep it mostly for academics. So it means it's not usable for enterprises. So we took the Llama like paper and implemented from scratch completely in Apache 2, and we open sourced it. So it's fully usable for enterprises. But we also gave you the training code, not just inference. And we also gave you fine-tuning methods as well. So they're all in there. Now the repo has Lightning in it, so it's very simple. There's not a lot of boilerplate. It's very readable. It's like 1 or 2 files for most things you want to do. It's not hundreds of files, and we want to keep it super minimal. Now, the weights are not there. Obviously, you have to grab your own weights, but we will be training LitLlama with community as well to then open source the weights. But that repo, we have collaborations with all the big hardware companies where we have engineers there that work with us to make sure that they run really fast on GPUs and TPUs. Like, I don't think you're going to be able to make models more performant than the people who built the hardware themselves. So that's what these repos are going to be. It's really like the fastest LLMs possible that you could have.
And are you planning, or maybe you are already, to offer it as a service, or is that open source and for people to do whatever they want with it?
Yeah, I think probably unlike most other companies that are out there today, like we actually don't really care about models. Like, our business is to help enterprises build and adopt AI, not to power APIs. So it's actually, our incentives are actually truly aligned with the community, which is like, we just want to give you the fastest models because we know that we can build things like this. And you're going to need to run them, right? So we can help you run them and do all that stuff. Or you can do it on your own, that's fine. But no, we're not going to be offering like services and APIs and all of that. And really that's so that we can have the same incentives as the open source community.
So I've heard you in other interviews say something very interesting. So you're as deep in the space as it gets, but I've heard you basically offer words of caution to people, especially enterprises that want to deploy LLMs. Can you explain why?
So it's really hard to tell at a glance how useful something's going to be when you go to the chat GPT UI and you play with it, because it's good, right? And like I use it all the time. And it is great, and you're like, okay, you can from there you're like, okay, I can like take this immediately and apply it to my company. No, you can't, right? Like it's a big gap between a UI where you can chat and even an API to a production-ready system, because you need to have auditability. You need to be able to trace what happened. Like your data's private. I mean, all of this stuff is going to OpenAI, right? So there's so many things that go into this. First is the viability, like how hard it is to actually put this stuff into production. But second, like the model lies a lot, right? And unless your product is like a creative product where like lying is actually a feature, meaning like if it hallucinates something, it's a better image, right? Then that's cool. But like you don't usually want your models lying. In those cases, you need to be very careful. So even from a research world, it's really unclear as researchers, how do we keep it from doing those things? It's a lot of like ad hoc rules and things you have to do to it. So like we haven't really figured this out in research. So I wouldn't go all in on this unless you can have like a human in the loop who's like helping. So before all this stuff happened, I had a startup where we helped low-income students figure out how to pay for college over text message. And in what we did, and this is 2016, 2017, before Transformers, we gave you suggestions. We had a whole dashboard for our internal employees where we gave them suggestions on what to say, but we also had a human in the loop. So I think that probably one way to adopt AI today, especially these LLMs, is to have this kind of human in the loop situation. I think it's too early to do it otherwise. And the problem is like it looks so good that you are kind of like bought into like, oh my God, it's going to work immediately. So everyone's rushing to it, but like you have to be very careful. Like take your time with it and like actually evaluate it, because if you do it wrong, like there was like Zillow or someone, like they did something very wrong and like it really tanked their business. So, one rogue model can really have a huge impact very quickly.
Do you have a rough prediction on when that problem might be solved? Because, I think we're all experiencing this crazy moment right now where everything feels exponential and compounding, and the problems that seem to be intractable recently suddenly are solved. Do you think the hallucination problem is something that's going to stay, or is it going away?
So it's funny because if you were like doing a PhD or you were in research, we've been feeling this for many years already. Like there was like 100 papers a week, and you're like, how can I possibly read all the papers? You couldn't, right? Today, it's kind of like, okay, the world realized that this is a thing, so everyone's feeling the same way now. But in the research, we've been kind of feeling this for a long time. So I think it's still going to be I don't know, like 5 years probably. Like I don't think it's going to be like one day suddenly it's solved. I think it's going to unlock industries sequentially. So like year one, maybe we can do this industry and then this one. But like healthcare and finance are like the last ones that we'll have that we'll actually be able to do there.
And why is that? Is that because it's mission critical and you need to get it right? Or
Well, because those are the ones you have to audit usually. So
okay. Because they're regulated industries.
Exactly. So we work with a lot of banks, and when a model goes into production at a bank, you need to be able to explain to the SEC why that model went into production and how and like all the things that happened to it, right? So I remember I used to work at Goldman Sachs on the trading floor. This is 2018 probably, and or 17. And I wanted to use deep learning on the trading floor to suggest trades. And my MD looked at me. He was like, hey, so like Netflix, if you recommend a wrong movie, it's fine. But like if we recommend a bad trade and you lose $1 billion and you can't explain it, that's different, right? I think that's still true today.
There is a little bit of a new political economy that is getting formed around generative AI. You mentioned Little Llama as an open source project. Where do you think open source falls, compared to the open AIs of the world, and why does open source matter?
So I think all roads lead to open source at the end of the day. No matter what you do or how much money you have, you cannot compete with the world's resources put together to do something. So some companies will have an edge for a bit, yes, but open source will catch up, and it'll catch up very quickly. It will always be open source. AI came from open source, came from academia. Like, trace it back to the very beginnings. Some of the early stuff that Jan was doing was always open source. And in fact, I think that's why FAIR is probably one of the best open source labs today, because of that DNA. So it will always come back to open source. Open source, the role it plays, for me, it's about giving back to the community. It's about sharing knowledge. If you've been in other sciences like neuroscience where nothing's open source, progress is super slow. Like, you want to get a data set, you can't do it. You ask a lab and they're like, no, but I grew this monkey for 3 years. I need to publish on it. And it's like, okay, well, it'll take a long time. AI was exponential. The reason why we're here is because it was open source. So turning your back on the community today, you can do it. It's your business, and you do what you do for profits. It's fine. But, like, none of this wouldn't exist if Google hadn't published Transformers and put the paper out there, right? None of this would have existed if the attention stuff would have been out there, if the ANO hadn't been created, if TensorFlow hadn't been created. Like, all of this is built in open source. Even if you're going to make money on it, it's fine. We all are making money on it, but it's all built in open source, and you should like honor that.
There's an emerging stack around AI in general and generative AI in particular in the enterprise that you guys are very much a part of. What else do you think is important? And I'm going into vector databases and LangChain and all the things. How does it all fit?
Yeah, good question. There's a lot of noise. I think there's a lot of interesting projects, and like, it's early research, so people are tinkering and trying things, but I would think about it that way. I think it's a lot of research. Like, what's going to last from there, I'm not sure. Like, probably 1% of the things. But like, I find it fascinating to explore and to like see, oh, cool, like, this is interesting. Like, okay, so you can chain together a bunch of prompts and things happen. That's great. How far can that take you? I don't know, but I think it's a research question. So like, if we were back in academia, no one would be criticizing these things because it's research and you should be trying things out. But I think because there's like VC money involved and all these other things now, it gets a little weird. So I think as long as you can maybe separate both, I think we're okay. But there is a lot of noise in the market. We tend to be agnostic to most of that because, we've been doing this for a long time and we kind of know what we want to be doing and we know exactly where we need to be. But we definitely look at see what's happening, and if there's like a real trend that might last, like, we will adjust the tooling. In fact, Fabric is exactly that. Like, there was a long time where we heard Pytorch Lightning users complaining, hey, but like, I don't have flexibility for this or that, and we're like, it's fine. And then inklings of, but we're like doing this thing called pipeline parallelism, and how would you implement this or whatever? And we're like, well, it's very easy to do in Lightning. Until eventually, after a few years, we realized, oh, these people are all doing this new thing called LLMs. And actually, there's a gap in the market for a tool for this. And so then we realized that the tool that we had was good for 2016 through 2019 deep learning, but as of GPT-3 deep learning, it wasn't good enough. And so we had to upgrade to this kind of new paradigm that we introduced. So the research changes and the tools will change as well. And we change with it.
I mean, obviously, there's been this arms race towards ever bigger models. GPT-3 for maybe one day 5 and all the things. On the other hand, there seems to be a bunch of LLMs that are smaller, perhaps Little Llama is one of them. I don't know. What does the future look like? Is that a race to having ever bigger models and whoever has the biggest model wins? Or is that a sort of polyglot future where you have a bunch of different models for different things and perhaps it all works together?
So if you kind of step back to original ML data science, there's a long history of compression, like autoencoders, where you're bringing things in, you're projecting them and expanding, or kind of going the other way. PCA is another good example. So I think if you extrapolate that, there's always going to be a pattern of go big to get some result and then compress it back. And I think that's what's happening right now, right? So like we needed to train for a long time, so we have these LLMs. That makes sense. We will now compress them, and that's happening. Little Llama, you can go big or small. You can have 7 billion. You can fit on one GPU. We love for everything to work on a laptop. Like that's great. I think that what people miss is when you have a massive model, it's like sexy to train something with 2,000 GPUs, but like, how are you going to deploy it? What are you going to do? Right? You really want things to fit on one GPU if you can. So there is a race to that. I think it's a matter of time. I kind of think that the whole large-scale model thing is really a gap in our scientific understanding of these models. Instead of looking at the math and coming up with a better loss function, we figured out that we could throw compute at it and get us pretty good results. But I think the math field will catch up and we'll have some fancy regularizer that will make all this go away. And now we're back to like a small model. So I think that the future is small, large language models, I guess, that are specialized. If that's just called CNNs, I guess. But
great. Last question from me, and then I'm going to open it up to you all. Maybe zooming back out, what's next for the company? What does Lightning AI look like in 3 years from now?
Yeah, so I think where we're focused right now is on these like really high performant models, and we're in that growth stage of the company, so we're helping a lot of enterprises revamp their current tool sets into this kind of new generation. What we found is most companies have some sort of platform that they built internally, and that's not scaling. And so they're bringing us in to basically say, okay, you guys know what you're doing here. Help us figure out how to scale AI across the org. Whether you're using other tools, we're complementary to all the tools, right? So the platform that we have is one where you can use all the things that you're used to already. So the company will be more of that. I really think about it as like, if models are the rockets that everyone's going to be going after, we're like NASA. We help you build them, we help you launch them, we help you, or maybe SpaceX is better, I guess. I don't know. So that's where we are, right? So we're really agnostic to this. We will provide certain high performance models because like Ferrari, we believe that we can build some of the best models around, and we will give them to you, and you just do what you're going to do with them, right? So it's more of that. It's more of that platform experience. And yeah, I mean, we will be doing a lot of things with the community. We'll be training models. We'll be putting things in open source. But probably in 5 years, Lightning is like the standard platform for you to do anything with AI. And it works with all the other tools in the ecosystem that you want to use as well.
Very cool. All right, as promised, I'm going to open up to questions. I can bring up the mic.
This is going to be a little... well, anyway, Cockroach Labs gave a talk here, and they were all open source. And then they ran into a issue with Amazon in using their open source for profit. And it seems like you've said you've put some things in place for that, or do you see a point in time that you might need to leave open source or not? Like, what's the difference between you and Cockroach not needing to do that?
So we're actually open core, so meaning most of our things are open source, and then the platform things are not open source. So when you run on the Lightning, so there's like a Pytorch Lightning Cloud. When you run a Lightning Cloud, a lot of the things there are not open source. Our orchestrators, our security, all the things that like you probably don't want open source as a company, are the things that we don't open source, right? Meaning, like, if you're a customer, you wouldn't want us to open source that stuff. But the core stuff that you can run on your own, you can, right? So we are probably, I mean, every cloud provider today can use Pytorch Lightning to train models, and they do. So that's already happened. It doesn't really affect our business too much because our platform, I mean, you go train a model on a cloud provider versus our platform, it's going to be 10, 100x difference. It's very, very different because we know how to configure the GPUs and what drives should you use and like how to set up buckets and all this stuff, right? So we really look at models holistically. The other thing that I haven't mentioned is we have an in-house Pytorch team. So we hired a lot of the core leads from Meta. So the person who wrote a lot of the compile stuff that you're seeing here, the linear algebra libraries, person who wrote all the profiling stuff, right? So we have unfair advantage in talent at the company as well, where we can really help you do things that are very, very unlikely to do on your own or at these other providers. But we won't be leaving open source. Like our DNA is open source.
Great. One more question here.
All right, thanks. So in the realm of research, how much headspace and time do you have to dedicate to sort of the ideas around like narrow AI versus general AI? And I don't know, I heard it framed this way. Maybe I hope it's helpful. And the question of like representation versus learning.
So my PhD was in basically, I mean, everyone's, I guess, in deep learning is representation learning, right? So how do you encode concepts? Most of the stuff that I did was contrastive learning, self-supervised learning, right? That led to a lot of the things that you're seeing today with vision. Back then, it was like CPC and other things that we were doing. As far as AGI, I don't really care about AGI. I don't even think it's a real thing that you can do. We're not AGI ourselves. I'm not even sure that concept actually exists. Like, if I were AGI, I would know everything about the universe, and I don't, right? So to me, it's really, we are specialized intelligence, and that's the case. Like, are we going to have really smart AIs? Sure, but like, I don't think there's going to be like a god AI roaming around.
So we say for now, we're not going to, there's no Terminator-like future.
We're all good,
okay.
Yeah. I mean, I think we would have time traveled back to now to tell us not to do this, right?
All right, cool. On this note, we're going to call it a wrap to keep it going, but this was fantastic. Thank you so much. We appreciate it.
Thank you for having me.